Assalamualaikum and hi everyone. My name is Nur Husna Sajida binti Taufikur Rahman. For our group, we choose redox reaction in energy power storage as our title in this presentation. As we all know, redox is a well-known reaction in general chemistry. It's a basic chemical reaction that happens every day or most of the time in life. Redox is divided by two reactions, which is an oxidation reaction and reduction reaction. An and reduction reaction is a type of chemical reaction that involves the electrons to transfer between two species. The redox reaction is any chemical reaction in which the oxidation number of an atom, a molecule, or ion changes by losing or gaining electron. A number of phenomena, both in physical and biological, are connected with redox reactions. This reaction is very important because this reaction is apparent from the fact that burning of different types of foods for obtaining energy for those domestics, transport, and other commercial purposes. Hence, redox reactions are common and vital to some basic functions of life, such as photosynthesis, respiration, combustion, and many more. Redox reaction are comprised to two parts, a reduced half reaction and an oxidized half reaction. Both of these reactions always occur together. When there is oxidized reaction, there will be a reduced reaction. The oxidized half loses electron and the oxidation number increases, while the reduced half gains electrons and the oxidation number decreases. There's another way to describe this reaction in a simpler way, which is all ring, meaning oxidation is lost and reduction is gained. Oxidizing and reducing agent plays an important role in chemistry, not only in redox. This reaction involves the loss of electrons in the case of oxidation or the gain of electrons in the reduction reactions. A reducing agent is usually a metal or a negative ion. It loses or can be known as donates electrons to another element or ion. It is also oxidizes itself to form an equation. Alkali metals in group 1 is the strongest reducing agent as they have low electronegativities and loses electrons very easily. Thank you. That's all from me.
Hello everyone, my name is Alifa Amani binti Muhammad Rafi'i. So today I'm gonna talk about my part, which is problem. The most common problem that will happen in redox reaction is corrosion. Corrosion happens when metal lost its electron, meanwhile oxygen gains electron, which means metal such as iron will react as oxidized substance, meanwhile, oxygen will react as reduced substance. For instance, when iron starts to corrode, it forms a red-brown hydrated metal oxide, or we all know it as rust, which is the result of corrosion of metal ion that does not provide a tight protective film, or we can say it does not stronger than before. It will get weakened. Also, it is easily to flex off that can cause the iron continues to react when it get exposed. Whenever it get exposed, it will become more weaker than before. Furthermore, rust will form when both oxygen and water are present. Next, in the corrosion process, iron metal will act as the anode in a galvanic cell and will oxidize to Fe2 plus, or we can call it as oxidation process. Meanwhile, oxygen will reduce to water at the cathode and we know it as reduction process. Let's see to the relevant reactions below. At cathode, we will we will get O2 plus 4H plus 4 electron, which is gain electron. Oxygen gains more electron, will form 2 mole of H2O. Meanwhile, at anode, Fe, which is iron, will lose its electron and will become Fe2 plus 2 electron. To sum it up, we will get the overall redox reaction, which is 2 mole of 2 mole of Fe, iron, plus O2, oxygen, plus 4H plus will form 2 mole of Fe2 plus 2H2O, or we basically known as. Let's move to the example of the corrosion process. First, Fe iron will oxidize at anode region of metal. Within equation, iron will form Fe2 plus 2 electrons, which means it lost electrons. For iron, it went through oxidation process. Meanwhile, oxygen O2 went through reduction process. At cathode region, O2 will get reduced. Within equation, O2 plus 4H plus 4 electrons, which means it receive more electrons and will form 2 mole of H2O. Next, rust, Fe2O3. Uh, Rust get from Fe2 plus that oxidize to Fe3 plus. Let's see through the second one. The second example of the problem in redox reaction is energy and cost of metals in redox reaction. As we all know, not all energy that had been released through redox reaction known as a useful. Sometimes it can be useful, but sometimes it cannot. Let's see through the example, such as fuel burns. In fuel burns, energy that release mainly known as heat. Sometimes the heat will escape into the surroundings, and some energy will release as a sound. As a result, when more energy got escapes, it will become less concentrated, or we can say it will become less useful. As for metal, corrosion will weaken the infrastructures of buildings and industrial equipment. As a result, it will cost the high value of money needed to get it fixed.
Hi, my name is Nusairam Nikman. Now I'll present about redox chemistry in energy storage. Redox comes from reduction and oxidation. Oxidation is loss of electron and reduction is gain of electron. These two always happen together. When one substance loses electron and another must gain them. In energy storage device like battery, energy is stored and released by redox reaction. This movement of electrons during this reaction is what produces electrical energy. Why redox reactions store energy? It is because electrons can carry energy, and redox reaction move electrons from one substance to another. When electrons move through an ester circuit, we get electrical energy. This is the basis of battery, fuel cell, and supercapacitor. Redox chemistry in a battery. At the negative terminal, we call anode, where oxidation happens that means electrons are released. At the positive terminal, we call it cathode, where reduction happens that means electrons are gained. Electrolyte allow ion to move so the reaction can continue. Electron flow from anode to cathode through the wire. Ion move inside the battery through the electrolyte to balance charge. Example reduction. For example, lithium-ion battery. At the anode, oxidation is happening. That means lithium atom lose electron. For this equation, lithium produces lithium ion plus an electron. At the cathode, reduction is happening. Lithium ion gains electron. From this equation, we call it lithium ion plus an electron produce lithium. The electron moves through the external circuit powering the device. The lithium-ion moves through the electrolyte. Energy is realized because electrons move from a higher energy stage to a lower energy stage. When we charge the battery, an external power source forces electrons to move in the opposite direction. Redirection are reversed, and energy is stored again as a chemical energy. Where energy storage is used. Energy storage is used whenever energy needs to be saved for later use supply when demand is high or made more reliable. Below are the main areas where energy storage is used. For the first one, portable electronic device. Example,
Mobile phone, laptop, tablet, smartwatch, and so on. These devices use battery to store energy chemically. Store energy allows the device to work without being plugged in, and redirection releases energy when the device is turned on. Next, the transportation. For example, electric car, electric bus, and trains. Batteries store energy to power motor, and energy storage allows vehicles to operate without fossil fuel. Some vehicles store energy from regenerative braking. Next, power grid. For example, grid color battery, pumped hydro storage energy during low demand and release energy during the peak demand, and help stabilize voltage and frequency of the grid.
The solution to the problem that has been stated is corrosion can be reduced by preventing iron from coming into contact with oxygen and water. This can be done by painting or coating the iron surface. Galvanizing is another method where iron is coated with zinc, which acts as a sacrificial metal. Oiling or greasing can also reduce exposure to air and moisture. Although these methods can help prevent corrosion, they are not perfect. Regular maintenance is needed to ensure that coatings or galvanizing remain effective. If the if the protective layers are damaged or worn out, iron can still rust, which means corrosion may continue despite taking precautions. Challenging protective coatings can sometimes peel, crack, or wear away, which exposes the iron and allows corrosion to continue. Galvanizing and other protective treatment can also be expensive and may not work for every type of iron structure. There are also self-healing coating that can repair small scratches automatically, which helps prevent rust and makes iron structures more durable.
Conclusion for our topic is: in conclusion, knowledge of the mechanism underlying redox reactions in batteries provide insight into their efficiency, behavior, and potential for innovation. Optimizing these systems will result in better energy storage solutions as battery technology advances, taking us one step closer to a sustainable energy future. The pursuit of battery design improvement reflects the insight of engineer Thomas Edison, who famously said, "I have not failed, I've just found 10,000 ways that won't work." Every obstacle in redox chemistry offers a chance for innovations that could revolutionize how we store and utilize energy.